Hey, welcome to our cold front presentation, and we're going to try to help you understand what these things are and why you should know about them. So when you look at this front slide here, you notice right here we've got the symbol for a cold front, and as we pointed out in the warm front video, you need to recognize the shape of the symbol. So cold fronts are associated with triangles. If you had it in color, it would be blue, but you're going to see a black and white triangle, so that's what you got to look for. So triangle shapes, just like when we looked at warm fronts, we had semicircles. It's going to work very similarly. Here you note that the cold temperatures are behind the triangle symbols, so the triangles go on the opposite side, and they kind of show which way the air is moving. So the air is moving from the cold into the warm because we name fronts by the type of air that is doing the advancing. So the colder air mass here is advancing into the warmer air mass, and that is causing the frontal boundary, like we learned about when we looked at warm fronts. So the two temperature air masses do not mix well, and that creates the cold front boundary, and we see that here. So we're going to get some similar results to what we had when we did warm fronts, where the air is not mixing and it gets separated based upon density. So as we saw with warm fronts, it's the warm temperature air that is forced to rise because it is less dense. Now the difference is the way that it does the rising. So note how the shape of the boundary looks different. The cold air is behind here, and it is moving in this direction, and that is causing the frontal boundary to move in that same direction. And what we're seeing is that the warm air that's out in front is getting pushed up rather rapidly. So the angle at which it gets forced up is much more vertical than what we saw with a warm front, where it was a much more gradual rise of the air. And that has consequences. That is going to change the shape and the type of the cloud that you get. So we end up with different patterns in terms of the weather we experience when we have a cold front versus a warm front, because of the way that the warm air is lifted in the process. So what do you get? The weather that you associate with a cold front is going to produce clouds that look kind of like this one perhaps, and they could look a little bit scary, and that's a cumulonimbus cloud. So one of the things that you're going to see is that the temperature of the air that in your location is going to drop very quickly when the front passes through. You'll also have it tend to be associated with heavy rain for a short time, but that isn't always true. Sometimes the rain isn't that heavy. Sometimes you don't even get rain. There are times where you can get a cold front moving through, and there just isn't enough moisture in the air out in front to cause precipitation. So, it's the case where you would detect that change just by looking at the temperature drop. But we also pointed out that you can produce these very tall, towering clouds called cumulonimbus clouds, and these would be the clouds that we associate with thunderstorms. You will get more detail on those when you watch the thunderstorm presentation. So the air is getting shoved up rapidly. That causes adiabatic cooling, condensation, cloud formation, and we get these tall, towering clouds as long as we have instability in the atmosphere. And that means that the conditions are favorable for the air to just keep rising, that the density of the air at the surface is much lower than what it's rising into. And so as it keeps rising up and it's expanding, it's cooling, it's releasing energy, and that keeps the density low, so therefore it keeps rising. So the cold fronts, if we were to compare the speed at which it travels to that of a warm front, we're going to notice that cold fronts are going to move much quicker than warm fronts. And it makes sense because, after all, it's the more dense air now that's going to be doing the pushing. So that would mean that the whole system will move faster. And we'll close out with this slide where we look at just the way that the cold front would progress across the United States. And so here we're showing the boundary of the cold front between the two air masses. The cold air is now over St. Louis, and they are out of the storm. It has already passed through them. Indianapolis, though, is getting the thunderstorm, and so they're getting the heavy rain that would be associated with it. And there isn't necessarily a whole lot of warning for those towns and cities that are out in front of this cold front. We had the telltale signature of cirrus clouds progressing to lower and lower clouds when we had a warm front. That pattern doesn't really hold true with a cold front because the majority of the cloud formation is taking place right next to the front where the air is being shoved rapidly up and you get tall vertical clouds being developed in that particular region. So that does it for this presentation on cold fronts. If you would like to find out more about thunderstorms and how they work, check out that video.